Hi everyone. In this tutorial, we will cover first classification problem in our tutorial series, Logistic Regression. So in our previous video, like in simple linear regression and multiple regression, our dependent variable was continuous variable, like sales where we have infinite categories. But the situation where you have finite categories for your dependent variable, target variable, those type of problems comes under classification, and for that we will perform here logistic regression. So basically logistic regression does not have the continuous variable. In logistic regression we have the discrete variable. Now in linear regression we can't perform this because my values are not discrete values. Let me give you some of the examples of logistic regression here, like predicting if a given credit card transaction is a fraud or not. So on the basis of our independent variable, we want to predict that transaction is fraud or not. So that means we have a discrete output, two outputs only, like yes or no. So this is one of the example of logistic regression. We have listed some other examples also, like customer will buy the life insurance, yes or no as an output. It's not a continuous variable. Email is spam or not, predicting if a customer will default or not. Order delivery mode, that means on the basis of other inputs we want to predict, well, this order is a second class, standard class or first class. This is type everyone, this is first class. Now in this case you can see in all the above cases we have only two outputs, like here fraud or not, spam or not, will buy the insurance or not. But in this case we have three output. So when you have two output, that type of problem comes under binary classification problem. And when we have multiple outputs in a dependent variable, but again the variable is a discrete variable, we have finite categories, is a classification problem, and here we will cover for that logistic regression to predict that. Now when you have multiple values in your discrete values, that is a multiple classification problem, and when you have only two values, that is binary classification. So the very first example which we will cover here is a binary classification example everyone, and in the second part of this video we will cover the multiple classification. Okay, now let's start with the linear regression because we have already covered this, and this will help us to understand what logistic regression is. Here are few data points which you can see. We have created one scattered line here using this, and on this line if we apply everyone linear regression equation which we have already covered in a previous video, which is y equals to b0 plus b1 x. If we use this simple linear regression equation to create a best fit line, which you can see, this is our best fit line, right? And these are the data points, and data points are only with value of 0 or 1. We have a discrete values for our dependent variable, and this is our independent variable. But this is not a best fit line which we can use to predict for predictions, correct? Because this is not on the this is not taking all the data points in my chart. But what we do, instead of using this, where let's say I want to predict this on the basis of cutoff of 0.5, that here program will ignore some of the points here, and here program will ignore some of the points here. Well, customer will go for the that this email is spam or not. But instead of this, if we use sigmoid function for discrete variable, this is the sigmoid function everyone, where the equation becomes 1 equals to 1 plus 1 by e to the power z, where z is your equation, regression equation, and e is your Euler's number, which is constant, which is 2.71828. When we use this sigmoid function for discrete variable, we get curve like this, which is more satisfying compared to the linear regression equation for discrete variable. Okay, so here you can see this is only picking on the left hand side for prediction few points, and here this is ignoring few points here, but this is picking good number of points here on the basis of, you can see cutoff is close to 2. We can ignore these we can consider this as an outliers, or if you have some data points here, or if you have some data points here, but close to 90% data points program has covered, and we can use this model for the predictions. Okay, so again let me repeat everyone, like this was our simple linear regression equation. Here we have a function which is sigmoid function we use for logistic regression. Logistic regression we use when we have a discrete dependent variable, target variable. Okay, now let's perform the same using dataset on our Jupyter notebook. Here we have a blank Jupyter notebook. Let's save this first as logistic regression. Okay, so we have successfully renamed this, and now let's import the library. Import pandas as pd, and we want to create one data frame which is pd.read Excel file, and Excel file which we have stored at this location inside ittoolstraining Python machine learning folder. Okay, and let's check few data points from this, few records, and you can see we have only 2 columns in this data set, and this is everyone binary classification problem. Let me write quickly, binary classification problem. Reason why this is binary classification problem, because we have only 2 output, 1 or 0, and the data which we have here is, well, we have person's age, and we have that this person is insured or not, he has purchased insurance or not. Now we want to train our model on the basis of this data, and we want to predict for some other customers. We have their age, and we want to predict that, well, this person has already bought this insurance or not. Okay, now what we do next, let's create chart visual. For that, let's import mat from a pyplot from matplotlib. Import pyplot as plt, and we have to use magic line here to render the chart. Matplotlib inline. Okay, and now let's create plt dot scatter chart we want to create. Let's check the visual, the type of data we have here. Let's create the scatter plot for this, because we want to add one best fit line on this. df dot age is my x-axis independent variable, and we want to predict df dot insured status. We want to predict this variable. The marker which we want to show this in as this asterisk, and the color which we want to give to our dot, it's blue color. Okay, now let's show this. Shift enter. Okay, we have a typo here, that is scatter. Let's fix this plus, and we have one more here which is matplotlib. Hit enter, and you can see we have a scatter plot chart here. Now the situation is the same, everyone. If we create on this linear regression line will come like straight line like this, but we don't want to create a linear regression line. We'll use here Sigmoid function, and we'll take help from our again sklearn library, scikit-learn library, and using that we'll perform the logistic regression, everyone, on this. Okay, so let's from our sklearn first. From sklearn, let's create training and test datasets. We want to split our data from sklearn dot using model selection import train test split class, and from that we have to create xtrain, xtest, ytrain, ytest datasets using the train, test and split functions where data frame. Now here first we have to pass our independent variable. So independent variable is a single variable, only one dimension we have in this, but when we pass in train test split we pass multi-dimensional, so we have to pass this between two braces. Now this is multi-dimensional. Now next is df dot ensure status, which is a dependent variable which we want to predict, and test size we want to give is 0.2. okay, so 80% of observation we want to use for training, and for testing we want to use only 20% of observations. If you want to check, we can check our x test values here. So these are our testing values for this data set. This has program has picked randomly, and for this we want to test our model. Well, they have purchased or not, we'll compare it later. So here we have splitted successfully our data into training and test everyone. Now next is we want to fit model. So for fitting model, again we'll take help from sklearn dot linear model library. We want to import logistic regression class. Now using this we'll create one object, and the object which we are creating here is model object, which is logistic. Using logistic function we have created one object which is logistic model object, and now we'll fit this model object on our X train and Y train. Okay, so once we will fit this, here we have a warning which is based on version. So this is saying that okay, default solver will be changed to LBFF in the version of 0.22. So what we do, let's use the same in this also. So solver is equals to, in my logistic regression function, to create the object we are using LBFGS, which program has suggested us. Let's shift enter, and here we have successfully fitted our model on the training dataset. Now what we want to do, we want to predict values. So to predict values, let's create ypred, which is equals to model, the object which we have created, and dot predict is the method which we will use here on the X test. Okay, shift enter. If you want to print the values of ypred, you can see the values are 1 0 0 0 1, and if you want to also check the values of y test, so y test are the actual values, and ypred which we have predicted here. So this is what we have predicted, 1 1, which is matching, and then you can see all 5 are zeros, so then we have 5 and then 1 and 1. So this is, if you check, as we have a very small data set and most of the values are when we have plotted this using the Sigmoid function, because logistic regression use Sigmoid function on discrete variable, which is binary classification case here, program is automatically converted this into binary 1010 form, and then you can see this is 100% matching here, which is not the case with every data set. That purely depends on your training data set, that your output will come 100% or not. If you want to measure that, what is your score here, which we use for model accuracy and which we have already discussed in our R-square and adjusted R-square video for linear regression. Now if you want to check the accuracy of our classification problem of logistic regression, you can use model.score, hit enter, Okay, we have not defined our x and y here. We should define our x and y here. So let's define x test and y test here, and on the basis of that, let's check the score. Score is 100% here because all the values are matching completely. Now again, let me repeat, which is not the case with every dataset. That purely depend on your training dataset, how much accurate that dataset is. So what all we have covered here in this video, everyone? We have covered one logistic regression where we use Sigmoid function to create the best fit line, and when you have discrete variable, we use class that comes under classification problem, and we perform logistic regression, everyone. This one we have closed here, binary classification. Next we will cover example of multiple classification. Thank you everyone. Have a nice day.